All right, welcome to Monday. Hey, it was good to see you guys on Friday during the assembly. I had one person, only one person. Sarah was the only person who emailed me and said, Mr. C, you screwed up and you did not put any answers from the previous work on Friday. Meaning, like on Friday's class, you couldn't answer Google Forms question number one because I didn't even tell you what the answers were. So we'll try to do it right today. So you had a worksheet. It was on the similar triangles, and here are the answers. So go ahead and check your work, grade it, and then answer this time correctly. Question number one on the Google Forms. Oh, and thank you, Sarah. Okay. So let's see what's going on. We're going to start something that is not in the book. For the next 2 weeks, we're going to do something that is not in the book. It's a continuation of Pythagorean theorem, basically, and I'm going to. There's some cube roots at the very end, and so I can't call it, 10 point something. So AD means additional. So there's two additional things that I'm going to be teaching you, and the additional thing number one, I need 2 days to do it. The additional thing number two, I need 2 days. And the last one, additional thing number three, is cube roots. I just need 1 day to teach that. So we're going to do three additional things. Do not panic. It just basically uses knowledge that we've already garnered from the classes and applying them in a different for different scenarios. Okay. All right. So quiz on Friday. We'll talk more about what the quiz will be on Wednesday, and it will be a multiple choice quiz. All right. So your homework will be a worksheet. You can find it at the bottom of the Google Forms. And here we go. So, yeah, we know about the Pythagorean theorem. Notice that we've only done the Pythagorean theorem in 2D. I gave you a triangle. Now I'm going to give you a three-dimensional shape, and you'll be using the Pythagorean theorem. So, I mean, the big thing is that it's really not that big of a deal, right? It's still just the Pythagorean theorem. So if you were a pro at the Pythagorean theorem, you'll be a pro at this as well, too. We're just going to apply it to three-dimensional shapes instead of two-dimensional. All right, so there's three objectives right here. Slant height shouldn't make much sense to you, but it will by the end of the class. Recall, Pythagorean theorem deals with right triangles. Okay, and the side that is opposite the right angle we call C, and the two other sides, which are called legs, we call them A and B. It doesn't matter which one you label as A or B, but the two sides that form the right angle have to be the legs, and then the side opposite the right angle is the hypotenuse. Okay, and we call it C. And what Pythagoras said is he said that the sum of the square of the two legs is equal to the square of the hypotenuse. Okay, and you've already done a lot of work on this. All right. The one key note here is C is always, or the side that is opposite the right angle is always, 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 always the hypotenuse, and it's C. Okay. So we're going to do a pyramid today. So do you guys remember how to draw a pyramid? All right, you start off with, yeah, we're doing three-dimensional shape in 2 dimensions drawing. So you don't draw a true rectangle. You draw a parallelogram. Otherwise, it doesn't look right. Above the parallelogram, you put a dot, and that'll be the vertex of the pyramid. And then you connect that dot to the vertices of the parallelogram, and you got a pyramid. All right. Today we're going to be doing something called slant height. So here's a pyramid of Giza in Egypt, outside of Cairo. And slant height, easiest way is to think of yourself if you were allowed to climb along the outside of this pyramid. You had a couple of options. You could travel up one of the corners. You could also travel up the center right there. And by the center, I mean um, along one of the bases to climb the perpendicular distance between one of the sides of the base to the vertex. And we define that as the slant height. Notice that's not the height. The height goes from the middle. This goes along the outside. So please write this down, the slant height of a pyramid. It's the perpendicular distance measured along a lateral face. That's what the name of the sides of a pyramid, lateral face, from the base to the vertex. From the base to the vertex. Remember, the base here would be a rectangle, and so we're going to go along there, and it's got to be a perpendicular distance, so that's why it's kind of in the center right there. Okay, so that's what's called the slant height. Kind of makes sense. Now, think about this. If I were to draw a pyramid, okay, we just drew one. There's my pyramid. and I were to measure the distance from the center of that rectangle, remember it's a parallelogram here, from the center of the rectangle, the base basically of the pyramid, to the vertex, we call that the height, right? That we've already written that one down, right? The height of the pyramid, the perpendicular distance from the base of the pyramid to the vertex. Well, this is not the slant height, that's the height. If I were to draw the slant height on this pyramid, it would look something like this. And here's the deal, what we're doing today. We are going to combine those two red segments right there. We're going to combine those two. In other words, we're going to link them together at the bottom, okay? And guess what we just formed? Yeah, we formed another right triangle. So go back to the Pyramid of Giza, right? There is your right triangle that you just formed. The slant height would be the hypotenuse of that right triangle. Hence, if we were to calculate the distance of that slant height, we're going to use the Pythagorean theorem because it's a right triangle. Okay, so the height of the pyramid would be on that part of the triangle. Well, the other part, right? The other part, I guess call it A, doesn't really have a name to it, okay? But it would be half of the base length. Think about it. Go all the way across. That's one base length. So halfway would be the distance of A. It doesn't have a name, but you could call it half of the base. So we're going to use the Pythagorean theorem to calculate the slant height, and then there'll be some questions on what is the normal height, but we'll still use Pythagorean theorem. Okay, so here's how it works. Let's think about a square pyramid. So a square pyramid is a rectangular pyramid. It looks like, just look at the base there, it looks like one side is 16. Well, if it's square, that means all the sides of the base, the bottom of that pyramid would be 16. Okay, so it's labeled there, the green dotted line for height is 24. What's not labeled is the slant height, that's the hypotenuse of that right triangle in green there, and then also the bottom leg there, the short leg of that right triangle, right? Well, how long would it be? We'll take a look. It only goes halfway to the middle. If the base length one side is 16, that means that that particular portion there, that would be half of 16. In other words, that would be 8. So that's the easy one to calculate. So if we're trying to calculate the slant height of this pyramid, right, the green hypotenuse there, then we're going to use Pythagorean theorem. Well, I know A is 24. I know B now, B is 8. So I just plug those numbers in the Pythagorean theorem, and away we go. 24 squared is 576. That's kind of a common one. You might want to memorize that one. 8 squared is 64. Add those two together. How do we get rid of squaring? Isaiah, how do we get rid of squaring? Don't know? All right, somebody help them out. How do you get rid of squaring? That's correct. The inverse of squaring is square rooting. So take the square root of both sides. Okay, calculator time. Square root of 640. Now this one is not one of those perfect squares. So let's today for the worksheet, let's round to the nearest whole number, or at least maybe the 10th. We'll call it the 10th. I'm going to round to the whole number for class today. Either one is fine, nearest 10th or nearest whole number. So about 25. And there's no units here, so it'd be 25 units. Okay? Let's do one together. So here we go. So calculate the slant height of the pyramid. Remember, that's the green hypotenuse there. Or imagine yourself walking to the top of the pyramid along the outside, the distance that you would travel. Okay, if you need to draw a triangle all by itself to represent those three sides, you can. Now, check it out. It's a square pyramid, so that means that one side is 6, so half of that would be 3, so that particular portion would be 3. And it looks like the height of the pyramid is 10. So A is 10, B is 3. To calculate the slant height would be the square of whatever C value is. So let's see if we can calculate that. This one's pretty easy. 10 squared is 100. 3 squared is not 6, it's 9. And 100 plus 9 is 109. We take the square root of both. Round the nearest whole number, we get about 10. So about 10 units. Okay? Get the idea and the feel for it? Okay, so try this one all by yourself. Pause the video, get to the answer. Answer the next question. I believe this is question 2 on the Google Forms. And then play the video and check your work. How'd you do? All right. Let's see. How do we do? Chloe, what you get? Anybody want to disagree? No? She got it right? All right, well, let's see. Okay, well, let's see. If it's a square pyramid, So that means one of the sides is 30 of the base. So that means all the sides are 30. And we know that the b value of that green triangle there would be half of the base. So therefore, that would be 15. So I got my two numbers. The height is 42. The portion I need for the right triangle is 15. So that would be 42 squared plus 15 squared equals c squared. Ooh, then we definitely need a calculator for this. 42 squared is 1764. 15 squared, one of the perfect squares you're supposed to have memorized, is 225. We add those two together, take the square root of both sides, and we get about 45 units. 45 units. Got it? Okay, for those you need to see that again, rewind the video, play those three examples again. Okay, so what's the difference here? It says calculate the side length of the base of the square pyramid. So we're looking for the length of one of the sides of the base of that square pyramid. Well, how would we do that? Well, notice on the green triangle there, we got the height and we got the slant height listed. What we don't have listed is that bottom leg. Well, let's calculate that. So we'll call that B. So let's see, that would be 42 squared plus B squared is equal to 45 squared. See where I'm getting those numbers from? Okay. So that's 42 squared, that's 45 squared. Let's just do some algebra here. Like, what do we get rid of first? I'm going to get rid of that 1764 first. So I'm subtract 1764 from both sides. And I get that. Okay. And then the square root of 261 is about 16. So I just found that B is 16. Now the question doesn't say what is B, it says what is the side length of one of the bases. All right, well, if B is 16, then we know the base length is double 16, right? Go all the way across. So therefore, the final answer would be 32, about 30. And then remember, this is an approximation because we did some rounding. Does that make sense? Okay. Let's do a new shape here. New shape. Let's do a cone. All right. So how do you draw a cone? Remember, you start with an oval. You put a dot above the oval, and you connect the dot to the corners of that oval right there. Okay, makes sense? All right. When you draw in three dimensions, we make the backside dotted. Okay. So what would be the distance along the outside of that cone from the bottom to the vertex, right? That is what we're going to call the slant height of the cone. So it's got that same feel as a pyramid, right? So that is going to be called the slant height. And it will be a perpendicular distance measured along the lateral surface. That means just basically the side of the cone from the base to the vertex. Make sense? All right, so now we know a couple parts of the cone, right? So if you were to draw a cone, please do. Draw a cone for me. Remember, I taught you the bottom is called the base, and then I told you that the distance from the base to the vertex is called the slant height of the cone. So guess what I'm going to do now? I'm going to do the same thing I did with the pyramid. I'm going to connect the height to the slant height along the base, and guess what I just formed? Yes, that is correct. I formed a right triangle. So the slant height is the hypotenuse, just like it is for the pyramid, and that leg of the right triangle is called the height. And the other one we don't have a name for, although you could call it the radius of the base. Okay, makes sense? You know, the radius of the base, right, would be the radius of that circle. So once again, since we have a right triangle, we can use Pythagorean theorem to find either the height or the slant height or even the diameter or the radius of the base of the cone. So let's do one. So there we go. Notice I have listed there, I have the height of the cone and I have the radius of the base of the cone. So therefore, to find the slant height, or in other words, the hypotenuse of that right triangle, I just plug those values into the formula. So let's see, 11 squared plus 5 squared is equal to c squared, right? Pretty easy to do. Do a little bit of addition there. And the final step is, that's correct, take the square root of both sides. It will be an approximation here, so therefore we get about 12. Okay, makes sense? All right, let's do one together. All right, let's see. We got the height of the cone is 20. We got the radius of the base is 11. Plug those numbers into the Pythagorean theorem in order to calculate the slant height of the cone. So let's see, 20 squared is 400, 11 squared is 121. Add those two together. Take the square root of both sides. and we get about 23. Questions? Okay. See if you can do it all by yourself. This is the next question on Google Forms. What you get? Levi, what you get? Anybody want to agree? All right. So everybody seems to be agreeing with Levi. Let's see if you got it right. Let's see. I got the height is 60, and I got the radius of the base is 28. 60 squared, really big number. 28 squared is that number. Add those two together. Take the square root of both sides, and it looks like Levi was correct. Just don't forget, generally we have units involved, so the correct answer would be 66, approximately 66 units. Make sense? Okay. All right. One last thing. I will tell you this. I will not have the homework is going to be both on or only on the pyramids and the cone. I'm going to introduce this to you today. We'll do a couple of these together, and then for Wednesday's homework, we'll actually have some homework on this. All right. Check this video out. Wow. That's a lot of work just to make. Yeah, just to make a box. And if you notice, what are the humans really doing? Well, the only thing that humans are doing are those things that machines don't do that well, kind of the final touch-up work there. But you might not have realized how much effort or how much technology is involved in just making a box. So what does this got to do with anything? Well, the question I'm going to propose to you is this. What's the largest object, or lengthwise, what's the largest object that will fit inside that box they just made? Hmm. Well, let's think about this. Well, there's a box. Imagine that's with an opening there. What's the longest object that will fit inside that box? Okay. Well, you would think that, well, that would be the measurement of the length of the bottom, but we also could put it diagonally on the bottom. That would be a little bit longer. Well, it turns out that's not even the longest object that will fit inside this box. The longest object that will fit inside this box would be an object that goes from the upper corner to the opposite lower corner. Now you're like, well, what if it was curved or anything? So agreed, something longer would fit in there. But let's say the longest rigid object, right, that would fit inside that box there. Okay. So what does that got to do with the Pythagorean theorem? Well, think about it. How could we calculate, if we knew the size of the box, how could we calculate that long red object right there? Okay. So here's what we're going to do. Well, I'm just going to connect some corners. If I connect the left side to the red portion, you notice what we get. That it's correct. We get another right triangle. So this thing about what size box you need to put this object in, right, can be solved with the Pythagorean theorem. So in other words, I'm going to give you a problem that involves some distances. You're going to calculate what's the longest object that fits inside this box. Okay. So it seems like a pretty easy thing to do. It ends up being a slightly complicated. Okay, so here's how it's done. Now we're going to do 2 of these, and then, like I said, we'll reteach this on Wednesday as well too, and we'll have some homework on it. So here's the steps. Step number 1 is we're just going to look at the bottom of the box. The bottom of the box. Well, the bottom of the box has dimensions 3 and 4. So the first thing I need to do is calculate that diagonal portion right there. You see the one that I just marked? Okay, so let's see how we do that one. Let's see. We got 2 legs of 3 and 4, so we throw those in the Pythagorean theorem. 3 squared is 9, 4 squared is 16. You add those 2, take the square root of both sides, and we find out that that diagonal has a distance of 5. Rewind the video, play it again if you need to see that again. Okay, well, we're halfway there. Remember, what we're trying to find is this red distance right here. Well, I know that one side of that right triangle is 5, and I know the other side is 3. Now I have the information to calculate the length of the red distance right there. So we throw those 2 values into the Pythagorean theorem, 3 squared and 5 squared. We simply do the math. We're going to get to an answer, and it looks like approximately 6 units long would be the longest object that would fit inside those boxes. Remember, we're not going to consider something that's curved or anything like that. Okay? All right, let's do that one more time. So I'm going to give you a box. It's going to have the dimensions. It's got the length, the width, and the height of that rectangular prism there. And you're going to calculate what's the longest object, rigid object, that will fit inside this box. So that would be from one corner to the next corner. So step number 1 is you just do the diagonal of the bottom. Okay? It's got side lengths of, or legs of 10 and 8. So we throw 10 and 8 in the Pythagorean theorem for the legs and calculate the hypotenuse. That would be 100 plus 64. See where I'm getting those numbers from? So that's 164. The square root of 164 is about 13. So that diagonal there on the bottom is about 13. We draw our final shape. So our final shape is from one upper corner to the lower upper corner, or the lower corner, sorry, opposite lower corner, more precisely. So that particular, the last triangle there would have legs of 10 and 13, 10 and 13. So those are the numbers that I would throw in the Pythagorean theorem. Okay, rewind the video if you're a little bit confused on where I'm getting those numbers from. Okay, I've also tried, if you see there on the upper left there, I've tried to keep that first drawing I had there so you can just see where that triangle comes from. All right, so 10 and 13, that would be 100 plus 169, which is 269, and the square root of 269 is about 16. So notice the box has dimensions 10 and 8 for the bottom, yet I can fit inside this box something with dimension of 16 simply by putting it diagonally from an upper corner to the opposite lower corner. Okay, make sense? All right, try one all by yourself. Right, this is the last question on the Google Forms. Try this one all by yourself. How'd you do? All right, let's see. So we draw that diagonal down there. It looks like we have legs of 6 and 5. That's 36 and 25. 36 and 25 is 61. The square root of 61 is about 8. Okay, so we take that 8, we toss it in there. We draw our final shape. That's what we're looking for right there. And our final triangle would have legs of 7 and 8. Do that calculation. Let's see. 7 squared is 49. 8 squared is 64. 49 and 64 is 113. And the square root of 113 is about 11. This one's a little bit even harder to wrap your head around. Check it out. Look at the box dimensions, 6, 5, and 7. Yet we can fit something of length 11 inside this box. Now, I did do some rounding. Okay? All right. So that'll be the 3 things that we did for class today. That is your homework. If you have any questions, make sure you send me an email. And with that, we'll close the class, and I'll see you guys on a Wednesday.